Hello everyone, today we are going to look at differentiation of one trigonometric function, which is y is equals to sine x, and we are going to prove it using first principle. So let's go without wasting your time. Y is equals to sine x. If y is equals to sine x, then y plus delta y, small change in y, would be equals to sine x plus delta x. So if this is the case, then y, we can make delta y to be the subject where we are going to have sine x plus delta x minus y. So and y is sine x, we can just y that is equals to sine x plus delta x is minus sine x, which is the value of y. So and we can expand this y, delta y is equals to, based on that trigonometric double angle formula, we are going to have sine x cos delta x plus cos x sine delta x minus sine x. We just expand this particular part. This is the expansion of this particular part, so we can expand this to be this. So if you don't know, you can check it. So then our next step, we can factor the one that has sine x. So we have delta y is equals to sine x cos delta x minus sine x plus cos x sine delta x. The only thing we do here is that we bring this one closer to his distance, because they have, all of them have sine x, so that's why we bring them closer here, so that we can be able to factor. So we have delta y is equals to sine x into cos delta x minus 1. We factor sine x in this part, so plus cos x sine delta x. So we can divide through by delta x, so we are going to have delta y all over delta x is equals to sine x into cos delta x minus 1 all over delta x plus sine x cos x sine delta x all over delta x. That's we divide through by delta x. So since we are finding a derivative, which is the y by the x, we have to find the limit as this delta x approaches 0. So the limit as delta x approaches 0, it means of this delta y all over delta x is equals to limit at delta x approaches 0 of sine x cos delta x minus 1 all over delta x plus cos x sine delta x all over delta x. So this one is called spatial limit also, because this limit, so when you take the limit of this one and you take the limit of this one, the limit of this one, when you take it, it becomes dy by dx. So then the limit of this, when you take the limit, this is a spatial limit. Let's just show it clearly here. If we have cos x delta x minus 1, or no, cos delta x minus 1 all over delta x, this limit as delta x approaches 0, is a special limit and is equals to 0, and the other limit, the limit as delta x approaches 0 of sine delta x all over delta x is equals to 1. All these two are special limits, so we are going to prove it in a different video. So that means this one is going to be 0, then this one is going to be 1. So we have sine x multiplied by 0 plus cos x multiplied by 1. So dy dx is equals to, this is 0, then this is cos x, so cos x. And this is a very simple proof, so I believe you are able to get what I'm trying to say, and you have any question you can leave it as comments. Thank you.